Hello guys, hello ladies and gentlemen. My name is Isa Al Khaldi, and in this video I will explain this question 1 from lecture 8, which is about energy balance. So in this question we have the pump of a water distribution system is powered by a 15 kilowatt of electric motor whose efficiency is 90%. The water flow rate through the pump is 50 liters per second. The diameters of inlet and outlet pipes are the same, and elevation difference across the pump is negligible. If the absolute pressures are at the inlet and outlet of the pump are measured to be 100 kilopascal and 300 kilopascal respectively, determine the mechanical efficiency of the pump and the temperature rise of water as it flows through the pump due to mechanical inefficiencies. So this question is very interesting because in here we have W dot. Just 1 second, let me prepare the pen. Okay, so we have W dot electric, which is equal to excuse me. So we have W dot electrical, which is equal to 15 kilowatt. This is the first given information, and then we have also the electric motor efficiency. So we have the efficiency of the pump is equal to 0.9. And what else do we have? We have also the 50 liter per second, which is what? Which is the volume flow rate, but we have to make the volume flow rate to be 0.05 meter cube per second, because we have to divide it by 1000 in order to make it cubic meter per second. The diameters of the inlet and outlet pipes are the same, so D1 is equal to D2, which means V1 is equal to V2. Okay, so what else? What else do we have? So the elevation difference. The elevation difference is negligible. So this means obviously Z1 is equal to Z2. The next thing we have is that the inlet and outlet of the pump are measured to be 100 kilopascal and 300 kilopascal respectively, which means we have P1 equal to 100 kilopascal, and P2 is equal to 300 kilopascal. Okay, I think that's all what we have from this question. So let me put them in the boxes so to make them more clear. So first we have the efficiency of the pump. So we have an equation that says efficiency of the pump is equal to W dot pump U divided by W dot electric. So we have W dot electric, we have the efficiency of the pump, so we can say that this will be 0.9, which is the efficiency of the pump, is equal to W dot pump U divided by W dot electric, which is 15 kilowatt. I will substitute it by 15 only because I want this W dot pump U to be in kilowatt as well. So I will multiply this by this. So W dot pump U will equal to 0.9 multiplied by 15, which is equal to, let me calculate it, it will give you 13.5 kilowatt. So this is the W dot pump U. So I will scroll down and I need more space. So now I found the first part, which is the mechanical efficiency of the pump. Now I need to find the temperature. Sorry, for this question we are not needed to find the temperature rise because it's not that important. What we really need to find is the first part, which is the mechanical efficiency. So now we found the W dot pump U, and if you are interested to find it, I can find it to you as well because it's very easy to find the temperature. So first let's find the W dot the mechanical efficiency of the pump. Okay, so now we will continue. Now we need to find this using Bernoulli's equation. You know, Bernoulli's equation says m dot multiplied by P1 over rho plus alpha V1 alpha 1 V1 square over 2 plus GZ1 plus W dot pump U equal to m dot multiplied by B2 over rho plus alpha 2 V2 square divided by 2 plus GZ2 plus W dot turbine E plus E mechanical loss. Okay, so let me use another color if we have. Let's find another color. Yeah, I can use red for now because I need to remove some the things that are equal to 0 or the things that are equal to each other. For example, now we have Z1 is equal to Z2, so we remove them from the equation. We have also the velocity, as I said earlier, v1 is equal to v2. And we have also the W dot turbine. We don't have turbine, we have pump. We don't have E mechanical loss. So now we will rearrange the equation, and we would say M dot multiplied by P1 over rho plus W dot pump U is equal to M dot multiplied by P2 divided by rho, and that's it. So now we have to rearrange the equation in the best way, so we can just substitute everything. So now we will say, because we need W dot pump U, we have already W dot sorry guys, by the way, this is not W dot pump U. I made a small mistake. Just I need to remove this. Okay, so I need also to remove this. Yeah, and I need also to remove this one as well. So the efficiency of the pump is equal to W dot pump shaft. Okay, so W dot pump shaft divided by W dot electric. So yeah, so now everything was good, everything was right, but this is W dot pump shaft. So I just made a small mistake in the equation. So now 0.9 will equal to W dot pump shaft. So this is the shaft power that we need to find. So now it will be divided by the electric power, which is 15. So now W dot shaft pump is equal to 13.5. So this is the shaft power, guys. So just bear it in your mind, and everything is right. Now everything is right. So we now need to find the W dot pump U to find the efficiency of the pump. So W dot pump U will equal to now we put the other equation in the other side. So W dot pump U is equal to M dot P2 divided by rho minus M dot P1 divided by rho. We take the common factor, so W dot pump U is equal to M dot over rho multiplied by P2 minus P1. So the next thing we are gonna do is W dot pump U is equal to the M dot, and this do we have M dot? No, we don't have M dot, so we need to find M dot first. So let's find M dot first. So M dot, we need to find M dot, so then we can substitute. M dot or equal to rho V dot. So as I said earlier, the V dot is 0.05. And do we have rho? The rho is going to be yeah, it's going to be, I think we have water here, right? Yeah, we have water. So the rho is going to be 1000. Okay, so we will say that m dot equal 1000 multiplied by 0.05. Okay, so the m dot will equal to 1000 times 0.05, which is 50 kilogram per second, which is a big number, right? So now we got the m dot. Now we need to continue. So now we can say W dot pump U is equal to 50 divided by 1000 . Okay, so now we can say P2 minus P1, which is 300 times 10 to the power 3 because it is in kilopascal, minus 100 times 10 to the power 3 kilopascal. So W dot pump U is equal to just let me calculate it, 1 second. So it will be 300 times 10 to the power 3 minus 100 times 10 to the power 3. So this will give you 10 kilowatt. Okay, so we found the W dot pump U. Now we just need to use the efficiency of the pump. Now we can easily find it. It will equal to W dot pump U divided by W dot shaft. So this will be equal to 10,000 divided by 10 kilowatt divided by W dot shaft. W dot shaft, we found it earlier. It was it was 13.5. So yeah, 13.5. So this will give you, of course you have to multiply it by 100. So this will give you the efficiency of the pump. Just 1 second, let me calculate everything. So this will give you 74.07%. Now this is for part A. So now if you need to find part B, it's very easy. I'm going to find it for you guys. The temperature rise of water as it flows through the pump due to mechanical inefficiencies. So the part B. So we have we need to find first the E dot mechanical loss, which is equal to W dot pump U minus delta delta E dot mechanical loss over m dot times C. So the delta T, if we make sorry, this is delta T. Okay, so this is delta T equal W dot pump U minus E delta E dot mechanical loss over M dot C. So we have the W dot pump, we have M dot, we have C, but do we have the E dot mechanical loss? So to find E dot mechanical loss, we need to use this equation. Delta E dot mechanical loss equal M dot P2 over rho plus alpha V1 square over rho, over 2 plus GZ2 minus M dot P1 over rho plus alpha V1 square divided by 2 plus GZ1. Okay, if you now we need to remove the things that we don't have. As I said earlier, we don't have V2, we have V2, we have V1, but they are the same, and Z1 is the same as V2. So if you rearrange the equation, you will get M dot times P2 over minus P1 over rho, which is equal to 50 as we found it earlier. So multiply by 300 times 10 to the power 3 minus 100 times 2 to the power 3 divided by 1000. So this will give you the delta E dot mechanical loss, which will be 10 kilowatt. Okay, so now we found the E dot mechanical loss. We just need to substitute it in this equation. C is constant, which is 4.18. So now let's find the delta T. So we would say delta T is equal to W dot pump, which is 13.5 minus E dot mechanical loss, which is 10, divided by M dot, which is 50, multiplied by C, which is constant 4.18. So this will give you the difference in temperature, which will be equal to 0.017 Celsius. And yeah, that's it. We found the difference in temperature, we found the mechanical efficiency, and I hope you learned from my video. Thank you for watching, and goodbye.